So we are going to open one file, and it's the most important file in the project. What is the name of that most important file in the project? Anybody remember from last time?
SRC.
So SRC is the folder, and how do you pronounce SRC? Source. So you enter the source folder. In the source folder is the main folder. In the main folder is this deploy folder, which right now doesn't have much in it. We might look at that later. And then there's the Java folder. The Java folder is important because that's where all your Java code lives. Inside the Java folder is the FRC folder. Inside the FRC folder is the robot folder. And inside the robot folder are two files. One's named main, one's named robot. Which one do we care about? So I'm going to open up main just to show you real quick. There's not a lot in main. If you are opening the main file, you either know what you're doing and are doing something super advanced, or you're in the wrong file. In 99% of the cases, you should never need to open the main file. The file that we care about, though, is the robot file. So you can go and navigate to it that way, or I'll close it out. If you just press Control P, it brings up the shortcut where you can type in the name of a file you're looking for. And if you do this, always make sure you open the file that's a Java file. Don't open a class file, a text file. It should be a robot.java file. And then you'll get this structure. What's up?
Should it have like a coffee bug looking thing?
It might. It's possible, depending on what extensions you use. Like mine right now, I'm using just the default, and so it just shows a J. But if yours has installed on it the icons, and I were to enable these, then you'll see the coffee. But I will turn that back off so that we don't get that mixed up. Okay. So we did talk the last time we were here a little bit about this file, but I want to go back over it. These lines that start with 2 forward slashes, what are they?
Comments.
Comments. And what is a comment?
Parts of code that do nothing except tell you what that code does, or makes it easier to sort your code.
Mm-hmm. So the big thing to remember about comments is that comments are not code, right? It is just lines of text that when you convert your files into the program that runs, they get stripped out, they don't matter, they're just there to leave notes. Sometimes they're notes like copyrights, like right here this says who owns the copyright to this template, and what the license is and stuff like that. Other comments will be, hopefully, helpful bits of information as somebody who's trying to read the code, right? Now, that's not the only kind of comment. That is a single line comment. So those 2 forward slashes will give you a single line comment. These are multi-line comments. And that's just a comment that can span more than one line. Up here, this is not a multi-line comment. This is 3 one-line comments. This is not 4 one-line comments. This is 1 multi-line comment. And a multi-line comment just starts with a forward slash and an asterisk. Just one is all that it takes. And then it ends with an asterisk and then another forward slash. And again, same kind of idea, it just lets you type more information. One of the benefits of multi-line comments is it lets you use what's called Java docs. And we'll talk more about Java docs later, but that is a feature there. So anytime you see this text that has these forward slashes or these asterisks with the forward slashes, and in VS Code by default, if you're using the default theme, you'll get this green coloration on the text. All that's saying is these are comments that don't do anything, they're just notes. And you can leave your own and things like that. All right, any questions about the comments? Okay. So now it's time to look at the more interesting parts of the file. One of the things you'll find is every Java file has this line at the top. And this line is the package definition. Java has this concept of packages as a way of organizing your code. And the package just tells Java, where is this file? Does anybody remember, because I do think we talked about package lines, what this package actually corresponds to, or what it's related to? So it is a little unintuitive, but if you look, and I'm gonna change a setting on mine real quick, just so we can see this. And I want to, I think it's condense. I'm just gonna make sure we can see it a little bit better. I don't want compact folder. There we go. Okay. So I've turned off the compact folders so it's a little bit more clear so you can see where these are. But we've got this main folder, and inside the main folder is the Java folder. The Java folder is where everything starts. If I look in the Java folder, there's an FRC folder. If I look in the robot package, there's an FRC in the package. If I look in the FRC folder, there's a robot folder. If I look at the package, there's a robot in the package. So starting with that Java folder, frc.robot, Java, frc, robot. It's telling you how to get to the file. It's kind of like a map. Like, where am I? Oh, I'm in the FRC folder, I'm in the robot folder. So that's what the package is. It's a way of organizing your files. It's to know where a file lives. If I were to go in here and I would just create a second folder. So I'm going to create one called other in here. And I'm going to make a new file. Actually, I'm not going to make a new file. I'm going to use the tool. I'm going to create a new class command. Don't worry about this right now. So I made a file called testing. And it's in the frc.other package because it's in the frc folder and it's in the other folder. So that is what the package line is telling you. It's telling you, hey, where am I? Any questions about that? Okay. Yep.
Why don't I have a Java folder?
You do. So I am going to turn off this setting that I turned back on. There we go. If you look in the source folder, there's the main, and then in main there should be Java, and then there's FRC robot. Are you seeing that? Are you seeing that on yours?
Yeah.
Okay, so it's there. I was just turning off my condensing so that you can see all the folders. I'm gonna leave that off. Okay. All right, so after package, there may be a set of lines called imports. You may have these, you may not have these. It depends on the file. Some files will have no imports, some files will have a lot of imports. Did you have a question? Or you did? Okay. Imports are a way of saying, hey, I need to reference some code that's in another file somewhere. And the nice thing about imports is it can reference code you wrote in another file, or it can reference code somebody else wrote in another file in some other library. So for example, this thing. This package, right? It starts with the package, edu.wpi. Well, do we have an edu folder in our Java folder? No, we've just got the FRC folder. So right away I can tell, hey, this edu is not part of my project. It's somebody else's code that I'm using in mine. So I know that whatever code that person wrote is in this edu.wpi.first.wpi.libj package. That's where that code lives. And it's the timed robot is the code that I'm bringing in. If you look on line 15, there's a word there, timed robot, and that timed robot is coming from that import. And so what the purpose of imports is, it's so that you can isolate code and get code that is, in one kind of unit, and then you want to be able to reuse it somewhere else. So that when I make a project, I can use timed robot. When you make a project, you can use timed robot, and we don't have to rewrite all the code that timed robot has by default. Any questions about using imports and how imports are working there? If you want to know more about what an import is doing, you can right-click on that last word there where it says timed robot, And if you go to definition, it will pull up a new file. And if you look at the top of the screen, you can see the name of the file. Does anybody see a key difference between this file and the file we were just looking at?
It's a dot class.
It's a dot class. So robot is a dot Java file. Timed robot is a dot class file. And so that's an important distinction because we're going to make a note of that so that we have it. When you look at a Java file, that is effectively code that you are writing right now. It is code that you can edit, make changes to, run, build, fail, all that fun stuff you can do to a Java file. You generally can't. Now, I'm not going to say there aren't ways to do it, but they are very complicated and beyond what we're doing. A class file is generally thought of as something that is compiled. It is, hey, this code was written and it was bundled up, and now this is a way to use it. You can't make changes to it, but you can use it in your code. So for example, in here, don't want that one, I want this one. There's all this stuff in here. I can't type in this file because I'm in a read-only editor because class files are read-only. But you can see up here, here's that same package that we would expect to see. And now, here's another thing that's interesting. I'm going to collapse all this. If I open up my robot.java file and switch it over, oh, I didn't do it. Never mind that. But in the timed robot.class file, notice at the top here, actually, I get all these breadcrumbs. It tells me how to get to the file I'm in. Timed robot class doesn't do that. It's because it's not a traditional file necessarily. It may be packaged inside of something that you can't get to easily. But if you scroll through here, you can read the code that makes up timed robot. So if you're curious as to exactly how timed robot works, you can take a look at it, take a peek at it. But notice it's got the same comments, it's got a package definition, and it's also got imports. And it has a lot more imports. And those imports are coming from other places. All of these are coming from the edu.wpi.first.how, their hardware abstraction library, or layer. And then they've got this other import that's coming from the Java language itself, so a more common utility. But if you're ever curious about what something does in a file, 9 times out of 10, you can right-click on it, go to definition, and it will take you to the thing, if it's something that it can take you to. Any questions about that? Okay, so the next thing, we got the package, we got imports. All right, so the next thing we're going to talk about is are these files. So robot.java is a file. And main.java is a file. We're good with that so far, right? Those are both files. If you look in the main file, you've also got the word main here. If you look in the robot file, you've got the word robot here. If I were to look inside of timed robot, I've got the word timed robot here. The name of your file in Java has to describe what's in it. And by that I mean whatever is in your file, whatever name you give to the thing in your file, it has to be the same name as the file. If it's not, Java's not going to be happy. So to talk about what those are, there are generally 3 things that can go into a file. So you got 3 different files. One of these things is called an enum. An enum is basically just a list of things. Like if you want to say, hey, I need something to represent the days of the week. Cool, you've got a thing called an enum, and it's got values Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's an enum. We're not going to use it a ton in robot programming, but it is a very useful thing in a lot of contexts, and you will see them sometimes, and we'll talk about that when we see them. The second thing you might see is an interface. An interface is super important. It's a little bit more of an advanced topic. It's an abstraction kind of thing. A good way to think about it is your car, right? How many of you right now could tell me from the moment a key turns until the car moves, every step that happens inside the car in order for that to happen? I couldn't do it.
Mechanic probably could.
A mechanic probably could. Most people, I would argue, can't though. Now that's talking about the inner workings of the car. However, if you want to use the car, you don't need to know all that. You need to know turn key, put in reverse, put in drive, press gas, right? That is the interface of the car. It is how you can work with the car without understanding everything going on inside the car. And so in Java, you can define interfaces so that somebody can go look at what you're doing and use what you're doing, but not really understand what's going on the inside. At this point, does that idea make sense? Interfaces will have a lot more to them, and they're very important, and they're really, I really love interfaces.
Like on your phone, all the app icons, that's an interface.
It's a similar concept. Yeah, the words don't mean exactly the same thing, but like it's the same idea, is that you don't need to know
How it opens the app.
how it opens the app. You just need to know, I can open the app with this interface. Exactly. The third and final thing that we'll look at is called a class. Most things you encounter in Java are going to be classes or be represented by classes. The reason for that is that Java is what we call an object-oriented language. It is in the object-oriented paradigm, object-oriented programming. OOP. And the idea here is that if you've worked in a language like C or a language like Python that are primarily imperative languages. Now, I'm not going to say those languages can't do object-oriented stuff in ways they can, Python especially. Their primary way of working, right, is step 1, do this thing, step 2, do this thing, step 3, do this thing, and so on and so forth. And there's still some of that in Java, because Java is also an imperative language. So when you think imperative, you're thinking those step by step by step, do this, do this, do this. Object-oriented programming is a little bit different. It has imperative pieces inside it, but at a high level, you're actually looking at your program as objects, as things in the real world. And what that means is you could have an object called a robot. And in your code, you can make something called robot that has all the knowledge and behaviors of a robot. But it can also have things in it. For example, a robot has motors. So I'll say this robot has 2 motors. But there's other things outside the robot. For example, I can have a joystick. And that joystick can send signals to the robot, and the robot can have its motors do stuff and send data back and forth. The joystick doesn't know about the motors don't know about the joystick, but the joystick knows about the robot knows about the joystick, the robot knows about the motors, and the motors know about the robot. Right? There's that interaction there. So in object-oriented programming, you're really writing your program not as necessarily only a sequence of do this, do this, do this, do this, but as, hey, this thing and this thing interact. The joystick needs the robot to go, so the robot's going to go, and how the robot does that is up to the robot.
Telling one person to tell another person to do something.
Yeah, it's like a game of phone tag, right?
It's like having a program about one specific object and then connecting that program to a different program.
Yeah, so it's all one program, but at a level it does look like, hey, the motor is an object. It has its own program, its own things it can do, and they interact. And so it's that idea. And so in object-oriented programming, there's two kind of words that you'll hear a lot. One is object, and the other is class. The object is the thing, right? It has data. It does things. The class, now if you were here the last time, I used a word. If anybody remembers what that word is, starts with a B. The class is the blueprint. So the object has data and does things. The class describes what data can the object have? What things can the object do? The class doesn't do anything. And you can see that in here. So remember I told you we don't use the main? I'm gonna look at the main for a minute. This line right here, robot.base start robot, that is the line that does stuff. It makes a new robot, it makes a robot, and it has the robot do stuff. But robot.java is where we say, what is a robot and what can a robot do? And so for that reason, we've got robot extends timed robot. So this is a class robot, which means this is the blueprint for a robot. Which robot? Our robot. Not any other team's robot. This is the blueprint for our robot. Now with a blueprint, you can make one of something or you can make a lot of something. In this case, there's only going to be one robot, but you still have to have the blueprint. If I were to look at some other classes, like the motor class, for example, if that existed, it's one blueprint, but I could use it to make 20 of the same motor with just some little tweaks. We'll talk about that later. Any questions on the concept of a class and an object? Because this is a pretty core idea to object-oriented programming.